Hello. Man, I want to use this mic. I don't want to use the other mic. Hello. Finally. Who hit mute on this? Hello, welcome back. We are so back. Sorry for the technical issues. Okay. I said a bunch of stuff. Let me go back. It's working now. Okay. There's a bug. There's a little bug in the new build on Steam. Thankfully, that's not not an issue right now for the console builds because I've been making changes. And one of the changes that I made was a little bit buggy in accelerate mode. So I am going to make another build by end of day today. We still have a couple of hours before the new game mode goes up. So exciting times all around. So I was designing this level. Cool. All right. This is going to be our intro level. We're gonna have a bunch of these regular gunners, and we're gonna end with, just like in the first level, we're just gonna end with the sniper. So the player has to learn to dodge, deflect attacks. So that's going to be a nice intro for the player. Let's give them another thing to shoot here. Okay, so this is our intro. All right, we are focusing right now exclusively on the first the first campaign. Okay, the first campaign, manifest. Mrun 0. Are you sure this is correct? This is so strange, man. Uh, okay. So this is Mrun 0. And then we go to, this volume is pretty high right now. And then we go to the next level. And I think this is pretty tough. I don't want to throw the player into this immediately. So yeah, now we have to just like come up with combinations for these two mechanics. I have to throw the player into a little skirmish with, at least I think first we'll just combine the gunners. Like right now we haven't combined the gunners and the snipers. So I'm seeing one combination with gunners and one combination with chargers. That's a good mechanic, list of mechanics to explore in the next level. So let's do that. all these level names are going to get really confusing, but I will straighten them out later. So what are we doing here? Save as mrun a01. And this is messy. So let's open with a gunner and a sniper. Fast gunner. Fast sniper. Let's open with a tight spot. mrun 01. Pow, pow. What's going on here? Oh. Let's add the pow, pow. Balloon. I think this could use a little bit more verticality. Let's arrange for that. Here you can be 4, you can be 4. these should be the other way around. This one will catch the player's eyes first, and this sniper can sneak up on the player. Also, this is 2.5. Just making sure that entrance looks nice. There you go. Nice, nice. All right. Gunner. Okay, so this is, what is this? A gunner plus sniper combo. Should do a charger. We need to do a charger as well. Just to surprise the player a little bit again. Now let's double this up. Double trouble. Alive. Double trouble right here. You can be a charger. Let's see. Let's get a little overcrowded. It's almost a little bit too far out. It's really all about the angles here. Not bad. So charger, gunner, gunner, charger. What else can we do here? How about we hit the player with the double gunner? No, we want to first I am going to make the player go into one of these snipers head on. Gunner 4 user can flip and then we will do a double trouble gunner. Nice. I think what is up? Going good, going good. I just had to run out in the morning to do some paperwork, and after that I played some Helldivers with my buddies, and now I am back to designing some levels. How are you? He got me. Good morning. I woke up like super early, like 6 o'clock. Why is this guy not charging me? Charge me, senpai. Cancel. I just closed it. Yeah, I had to go to the office. Best to go early. This charger can be, this gunner can be flipped. And this charger can stay on the ground. Ta, ta, ta. Now this is what I call a level. Okay, and now let's do something a little bit more funky. What do you say? A little bit funky. I want to make a U-turn. Let's make a U-turn. This is height 4. This can be height 2.5. And here I'm going to add a block. Man, I love making levels on this. And here we can have a nice And here. But I really like, I want to drop the player in like the center of it. Should we use a portal? Ooh. Should we? Is it too soon for that? I don't think so. Portal. Like the player could just like go to the end of the corridor, enter a portal, and then bam, we're in the center of two of these guys, and they're just like pew, pew, pew. Is there another way that I can do this? I also have the warp. I actually don't need a portal at all. Yellow balloon teleport would be another option, yes. There are lots of options. There's also the transport. Like you can shoot a balloon and it just like pulls you out. But it would be like a little bit abrupt at this stage. Let's see what this feels like. 4, 4. This is 2.5, huh? This is 4. Yeah, okay. Let's see what this. Nice. It's like a little balcony section. I think it's if I load it up properly. You go in here, you can't see it. Pow, pow. Yeah, you know what? That teleport might just be our ticket out of here. I think one yellow balloon to celebrate this occasion is not a problem here. You know what? I'll take that recommendation. None. Sync. Yo. Yes, let's see what your level has to offer. 1, 2, 3, 4. Wait. 7. Okay. 18, 12. I'm assuming this is centered. Okay, and over here we will get a balloon. And as the player enters, they will be greeted by our little pair here of gunner snipers. Fast sniper. Boom. Boom. This is going to be like really difficult. It has to be a little bit more open, I think. We'll just separate them out a little bit so that the player has some idea of order that the game imposes. Nope, 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 nope. Open. And we can do the same exit here. 4 by 4. 4 by 5 is fine too. You can be 1. This is height 2.5. Height 2.5. Block 1. Okay. 2.5. 2.5. Okay. Ready? Are we ready to go? Just a few more additions. Okay, just to pretty it up. I have high confidence in this idea. Flat light, flat light. Let's decorate this. And here, I think it's all right. I think it's all right. We can just put some totems here. Cool. Let's go. Let's skip the starting section. Ah! Yeah. Yes, yes, yes. That's gonna work. That's gonna work just fine. I'm gonna split this up. I'm gonna split this up into half. So the player comes out. Good idea, man. Good idea. Good thinking. Surface 1. Empty. Let's contain this a little bit. I hope I don't run out of walls. This needs a proper entrance. Pow, 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 pow. Ouch, man. 2.5, 2.5, 2.5. They're all 2.5. What's wrong? Spawns, flat, floor light. I should actually try to like beat this without dying, because this is gonna be hard. I think you just have to strafe, and that should be enough. Just strafe, that's gonna be enough. Also, you have to time that first. Yeah, that's a hard level. Okay, so these walls, how are we feeling about these walls? They're actually not bad. I need more lights. And maybe some landscaping, shall we? Shall we do some landscaping, ladies and gentlemen? Tamashika is nothing without a little bit of Landscaping. Let's go. Also, this gap feels so empty. You know what I really need is like a starry floor kind of thing. We will solve that problem later. The first problem I want to solve is this exit. This is 2.5, this is 4. I think this is only visible if I skip this level, otherwise it would be fine. I think we can nudge the player a little bit to the right, so they know what to do. And I think a little totem action here and here would work wonders. Okay. You know, I'm actually thinking we should extend this. Let's extend it. Too far away. My walls are toasting. Just in this much, how is the walls toasting, man? I seriously don't have enough walls or what? Do I seriously not have log geom 2 log flood walls? Do I have log flood walls? World renderer, that's what I need. What is going on here? It's not spinning up a second. Why are you not doing that, sir? All right, we're going to jump back into the code for this. This is a problem that needs to be solved because in this mode, there will only be one biome and it needs to be able to section. You see that flood wall toast? That ain't Gucci, bruv. That ain't Gucci. We got to fix that. What's the first thing we have to fix here? The output log is pretty disgusting. Debug log world renderer. World renderer. That's not a very useful short form now, is it? With what? Is it? What is going on here? Flood renderer. this toString is just, it's kind of sus, bro. I'll say that. It's kind of sus. It's kind of ew. I am going to put this in the update. Okay, we'll do flood walls and flood renderer in the update. We will just do a if debug dot blah 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 jigs to string. Don't need the str anymore. Yes, yes, AI, I know you know everything. We can just, instead of this /n, we can just debug.console shards of k. Shards count also have to, count is the same. .toString. How about that? How do you like dem logs? I was going to code Fast and the Furious, Too Fast, Too Furious, but I don't know if it's a swear word. So I'm going to decide against it. Shards, I think this is the same code, right? toString, same code. Oh, there's also no shards count. No, that's the same. I think that's the same. Okay, now let's get another look at the shards. This I think is working just fine in accelerate mode and in transcend mode, because in transcend mode and accelerate mode we have a bunch of different biomes that get you know this. Wait, I'll be right back. Okay, volume, suppress menu volume, music volume. Music volume, menu volume, SFX volume. Oh, menu volume is SFX volume. The opening splash is like extra loud, huh? Okay. Let's log the world renderer. Sir. Aha. We have 5. There's this, obviously this is a very big problem. I'm gonna have to get into the code here. See, there's that. So I'll explain what's going on here, okay? All of the world is being rendered with little dots, kind of like Minecraft, but they're like actual quads, they're not voxels. And the walls are also lined up with them, so these are just like, you know, a string of like little squares. And so is the floor, all of it, like all the geometry that you're seeing, except of course the objects. So each of them, like there's like these 5 shards or 5 different sets of walls and floors and roofs, and each of them can only carry one material at a time. So because it's a batch rendering, right? We send all the vertices to the GPU and be like, hey, just draw these in one go. And it can't do that with multiple materials. It's possible to set up, but then you have to do more shader magic. I'm not doing that, because all the shader magic that I've done is like exclusive to like one material. So this is like all shaders, but that's like one shader. So when the game renders one batch, which is doing right now, you can see it's like B100 219. That's, I think, I have no idea what these numbers mean, but these are like the counts. All right, now check this out. This count is gonna run out. All right, technically, you see that 72432. That's like really close. If that goes to 0, we're done for. I'm gonna lock the internet. What just happened? You see this missing wall here? This ain't Gucci. Now let's see what order we have here. Flood renderer is below. Why did you cap out? See, it capped out. It's not using the second renderer at all. I thought this system was smarter than that. $32. Already toasted? Let's see when it toasts, okay? Still not toasted. I think when the next section shows up, it's gonna toast. Wait for it. You're looking at the comment, the little thing, the terminal. There you go. It toasted. This is happening because the uh this is happening because the shard is not, because like each of this is tough. So here's how it's happening, right? Like the flood, the flood is just squares on the ground, but each square is spawning the walls on each like square region, and they're going in like 4 directions. Okay, so if I'm standing here and I'm drawing a wall here, and the level is here, it's only going to draw the walls for this side, right? So it's looking for cursors for this in this direction only. Cursors direction. And these, I imagine, are counted. So this thing calls next. Next dir reconstruct fill. A reserve is greater than 10, greater than 0, or s dot empty. This reserve, This is just the cell wall reserve. So, it's the flood entry, not the actual, like not the actual squares that are being filled in the walls, but like just the one that owns them on the ground. So if those are available, it can keep, it assumes that there will be more, there will be blocks to available to place, but those aren't being counted together. That's why this problem. So if we run out of, wall pieces, but there are still like slots open on the ground available to put down. This is the cell wall reserve, right? Like this is buffer size 124. Cursors, Q. Cursor is also buffer size, huh? That is so strange. Active cell walls. Da, da, da. I'm installing my brain back into this code because I haven't seen it for a while. Cell wall. This is flood wall shard. When you call next, you pick out from one of these cursors. Yeah, it's funny how the number of cells that I have and the number of wall pieces that I have for each direction is the same number. Why is it the same number? It doesn't need to be the same number. This buffer size is 1024. Okay, fine. Where's the flood renderer shard? What is your buffer size, sir? 2048. Fascinating. So if I lay down a piece that has too many of the same direction of walls, that's what happens. It breaks. Just a little bit of math magic here should solve the problem. I'm trying to understand where exactly we're going to do that. This is like this number. Wait, if I just go to toString, flood rendered flood wall shard, update. Update shards.toString ID register active cell walls count. Active cell wall counts. Okay. Just 282. Just 282. That's it. So I think we have on average, obviously, because like the number of pieces we have for the walls is going to be lesser than the number of blocks we are occupying on the ground. Like that makes total sense, right? Like look at the flood right now, the flood. So you look at this map, right? This whole thing is 512 dots on the ground. Obviously, the wall count will be a much lesser than that, right? So if I go, let's go to level 3. Let's keep an eye on that number and see where it takes us. So this is a big room. Look at that occupancy number. Like it's just 180, 122. The number of active cell wall registers required is actually a lot lower. Look at that. These are pretty low numbers. 116, 58. And that's like one of the more like that's high occupancy sections of the game. Okay, big room. 22, 22, 145. Wow, man. What am I looking at here? Active cell walls. Active cell walls, cell wall reserve, buffer size. Okay, not digging this. Not digging this at all. This number could be a lot lower. What else are you rendering here? Let's see. So each direction, the wall can be erected on either edge of the square. That's the total count of those. Minus the maximum number. So 1024 minus the number of active counts. That's what you're seeing here. That's the remaining count. So this, yeah, it doesn't make sense. Flood renderer shard. Okay, let's get surgical. Flood renderer shard, flood wall shard. Okay, this buffer size, I'm gonna come up with another buffer size here. Cell buffer size can go down to 512, and this number, that's a big number. Here's another thing that we can do. You know, because like when it runs out, it actually is only checking to see if it's run out of like cells. Thanks for hanging out, man. Have fun. Say hi to your friend for me. Thanks for sticking around. I'll catch you in the next one. New updates tomorrow, by the way. So whenever you have the time to hang out with Tamashika, she'll be waiting for you. Buffer size. Buffer size. Buffer size. And 2048 is just a really big number. Buffer size. Adios. Buffer size. You see, this buffer size is not only being used here, but for each of these cursors. That's a lot of memory, dude. You know, if I make the decision to do this properly, there will be a lot of underlying changes here. Because like, for example, this level that we're designing here, this section, for example, you see, because this is like a height 4 wall and it's this long, it's placing pieces all the way here and then all the way back. What it's not doing is placing pieces for this edge and this edge. Like it's doing just this one and this one, but you see the asymmetry in the count. Do you feel? Do you feel the asymmetry? Dynamic vertex buffer size. You know, I'm going to consult my dust PS particle patch. Upload buffer size. Now this upload buffer, count. Now do you see what's going on here? What's going on here is that the number of particles that are sent to the that is sent to the graphics card are counted, but this is happening via bake. So this is a like the array is collapsed. Does that make sense? I actually fixed this, but I can't remember where I did that. This upload buffer, see, every time I bake, it collects all the, so some particles might not be alive. Less than count particles of I upload buffer. Particles of I dot data upload buffer. This is it. It's doing that sequential remove. So what happens is that the whole buffer, it remains ordered. So imagine an array, right? And I'm like, hey, I want to occupy these, this, and this, and then it goes in serial, and then it removes one, right? And when it removes one, it collapses the list back. This I can do here because it's actually just a particle system, but over here points. This is, man, there's way too much indirection here. There's way too much indirection here. Like look at that. Look at what's going on here. Points of a given wall direction have the index inside entries direction idx is set to point. So like over here, it's just setting it to 0. It's like, okay, don't render this, but it's still sending it to the GPU, which is, if you think about it, it's kind of costly. It's kind of costly. And what that cursor array is doing, it is keeping track of that queue is keeping track of what cells are available to be occupied. So when you fill, right, it takes out an available no. Wait, cell wall entries idx 0. I need a paper and a pen to describe this. The cell walls are static. They're like these structures that have like a pointer to the. I need my power glasses back, man. I'm sure you can tell, like when I try to describe like programming stuff, I can't. I can't do it in English. Like programmer types can, they have the language for like describing arrays and this and that. I'm just like, dude, I just know it in code. I don't do this kind of thing in English. I can't do this kind of thing in English. The problem that I'm trying to solve here is to get either get some way to find out that we've run out of walls, one, or make it dynamic enough that it can adjust. And right now, every add and every remove is O1. In the particle system, it's ON. Now there's a programming term that I understand. So making it ON would be pretty expensive. Man, I would really love to solve this problem. Dirty dir plus plus. I remember I wrote this code in Sapporo. Takes me back. See, instance vertex buffers I set data point size full buffer size. So it's like it's sending the whole list. If it was smarter about it, it would be able to just know the active count. This is a batch operation. I'm sure. Damn, dude. I don't know how I wrote this code. And actually, it looks at every cell and sees, okay, what wall pieces have to remove to what height and which ones have to be preserved, and it runs that operation. That's why I'm having trouble looking at this, because there's like, like a bunch of nested arrays here. That is obviously a little bit more difficult to read. Like, an easy way to like really like clean this up would be just to make a separate class. I'm thinking like it's just a separate class that has an interface to the cell walls, that the cells that are being placed, and just have like add remove routines on it. That's it. So that this piece, all of this code can sit separate from it. That's it. And like all of this like cursor next dir thing that I'm doing, that would be localized to like each of those those classes that are managing the data inside. But if I want to combine them, if I want to make it so that the buffers are more dynamic, then they will have to be a little bit more smart than that. So say I have 10 cell walls, okay, per shard, and I place 10 cell walls. I max it out, right? Now these could be so the maximum spawn would be like these like completely 10 separate points, right? 10 separate points on the map, and all of them are like height 4 meters. Each of them will render four-sided columns, right? And that's going to be like, what is that, 40 entries, not 40. It's, I think, the height is 0.5. It's going to be a lot of entries basically, right? And like the numbers don't check out right now, but that thing will toast if you do that. Now those 10 could be in a row, right? Just like one after the other in serial. Then you would have a lot of like the east and the west walls, but only one strip of north and south walls. That's why it's running out. It's running out because it's maxing out. I think it's maxing out the left, right, east, west walls. This is somehow too difficult for it to accommodate. Yeah, it zeroed out. Did you see that? Come on, man. Yeah, it zeroed out because right before I exited this, it spawned that one and it ran out of walls. So it's still Gucci. It removed that last wall. Now it's going to toast. It's going to toast for a second before it removes this thing. Yeah, but that it zeroed out and then it went back up. And it's only this one that's zeroing out. So you see it's like I think it's the second, it's this wall that's it's just like, yo, I cannot do this. I don't want to make it ON, man. If I make it ON, then it's just going to I don't know. I can't test this on Switch. That's the weakest, I think, the least performant platform that we are dealing with. I don't want to make any decision that wrecks the performance on there. But this is, I mean, yeah, this system is not the best. Because first of all, like the arrays are accommodating for like an average number of entries in each shard, but obviously like the level can be set up in a way where it's not balanced that way. Build wall matrix. Where's my geometry? Where did I put my geometry? Renderer.ibs. Ah, okay. Flood wall renderer. This is the. Okay, so these are kind of isolated. So this class doesn't. It's not very opinionated about it. Max height 16. This code is too spaghetti. Entries, direction, entry cursor. So every time it adds an entry, it has its own index that gets incremented. Oof. And cursor next. Oh my god. Wow, dude. Giga brain levels of spaghetti code over here. I wrote this. I did no. This is not AI written or anything like that. This is just me like in peak flow state where I was just like inside the code base. I was just like, wait, I just have to set up these arrays and there'll be these indices and they will keep track of the and then the code just like it worked and then I never looked at it again. And then now I'm like back and I'm just like, oh, like uh, this could be better. And when you look at code like that, you know, I was cooking. I was cooking over there. Hello, Vidvat, I'm you from the future. Maybe document, no, don't document it. Just write it cleaner. Write it cleaner, which I don't always like to do. Like unnecessary levels of indirection. No need for that. But over here, the thing is, because the way I'm placing walls, it's just it's not necessary. It we shouldn't be assuming how many walls per side should show up. That the max count there is obviously not working in our favor. We have to basically export. Okay, we have to export these cursors. My God, this is like an array of cues. So it gets the next. The system is pretty simple, but there's just like 4 of them happening in parallel. So if I look at the dust PS, when you add a particle here, sorry, particle batch, add, emit, is there any function here that's adding particles? Allocate, count. See, it's just maintaining count. And in the remove, it's just decrementing count. And this count 0 is just like okay, we're like there are no entries, right? And this generation test, like we're gonna have to do something along these lines, you know. um let's see, let's see. All right, let's see if we can come up with a version of this. Okay, count touched particles. uh Buffer size, what if this wasn't a hard stop? What if instead, okay, it was something like this? Hey man, it's a dynamic array. It's just do your thing, I guess. Particles, public wall entry. uh let's call them plates. Okay, particles, data. Okay, we're gonna get rid of this buffer size. Okay, give it a default value. If count is, you know, if count is, how do you expand a list? Okay, remove add, so it will never shrink. um That's fine. And this is, yeah, this would work as is. Remove add I, clear I, remove add clear. Now I think we're gonna have to have another data array. See, this is really expensive. This is super expensive. This is expense maxing. This is like this is like for the wall. We're gonna have to batch this or maintain a map. Wait, we'll come back to this. We'll come back to this. Let's see. Maybe, just maybe, this could work. Okay. This upload buffer. And what's the upload buffer? Upload buffer. Only for GPU upload of .data fields. I'm not gonna use this. I'm not, we don't need this right now. And this instance vertex buffer, we'll just maintain that over here. Instance VB bindings index vertex buffers. Instance vertex buffers. Declaration buffer size. See, this is, it already has a max size. It has a max size. So it can't be like fully dynamic. I can allocate a little bit more memory for it, but I think with this system we might save all the extra writes that I'm doing right now when the buffers are practically empty. So we can send the exact number of particles in each cell vol list. Could even batch the instance vertex buffer, so if they run out, could do more than one. Oh. I want to take a water break. I will be right back. Mammoth. Okay, you know what? Fine. Let us Oh, so when it removes, what is it doing here? Data of I. Sweet. It lifts the last entry and puts it in the. So smart, dude. So it's actually not an ON operation at all. That's O1, my friend. That is not ON. That is O1. And I think I was able to do that because before I had a structure of arrays. Sorry, I had an array. What did I have? Some programming term to describe how you put like the data across different arrays. Okay, so like if you modify one array, you have to modify all the rest of them. Uh, so I changed that for the particle systems. That's why this works in one call. Like I think you do like arrays of like structure of arrays when you want to be like super performant, like ECS style. Look at me, I'm like data first, which is fine, but until it becomes like a pain to manage, right? And I think you only reap the benefits of that if you kind of like avoid like what is it, cache misses and all of that. And if you're working with like really high counts, I'm not working with that like big numbers anyway, so it's easier to manage it this way. So this can be just a regular array. Data. Okay, so now we have a remove at I. We have a clear I, which is the same, so we don't need that, and clear count 0 touch true. If touch, so this will return true if not, okay, if bake, then bam, we copy the list. Okay, allocate. I need a setter here. What will be the remove for this? So I have points, I have IDs. See, this IDs is being added here. You see this ID's cursor is index. This index is what's coming in from so that's the index in the flood. So what happens is when I recycle, when this shard tries to recycle an index, it goes through all the entries and it attempts at recycling the cell wall direction all indices. Bruh, that is expensive. So like the cell just goes through all the lists to see if it needs to clean them out. No, not the whole list. Only the ones that are registered with the cell wall. See, it's maintaining a list of entries. You see that? So it is maintaining its own list, its own map of okay, just go into these lists and take out all of these entries, and they're all going to be O1 like O1 anyway. So if I go in here, so if I go into, stop playing with my hair, points, cursor. So this cursor thing, boy, do we need to get rid of that cursor thing. That's the whole point of this. That's what I'm trying to do. See, the cell walls entry in that direction with that index, okay, that one is being emptied out and is being put back into the cursor queue. Why is it doing that? So that it can maintain a list of available slots. We don't need to do that anymore because we're just going to add them in serial. So basically, this allocate is creating a count. We just maintain another list. It shouldn't be that hard. Yes, yes, AI, you know it. Okay, and over here, minus minus count, where C is equal to count. Data of I is equal to yes underscore count minus minus. So the IDs are also maintained. Now, what it is trying to do is delete by ID. I think that's what, like, see, so cell walls entry of direction ID X. It's a two-way. It's, man, if I can get through this code will simplify like mwah. Int IDX, int direction, and so this is just like the array slot, and this IDX. What is that IDX? That IDX is cell wall entries direction. What is that index, dude? I have no idea what that index is. So inside this cell wall, there is I think its own index. It is maintaining its, and in that, inside that array, which will be like 0 to 24 or something, it will contain the index. Oh, it will contain the index inside this array. That's how the entries are being populated, isn't it? Where is the entries being populated? There you go. It's adding cursor. See, we don't need to do this at all. We don't need to do this. All we need to do is maintain which cell wall index. You know what? I'm just going to rewrite this. Let's rewrite this. I think I'm pretty familiar with what's going on here. So I think what we do is remove at I. Public void recycle. Now, wait, not so fast. It does a full wipe. It's doing a full wipe on each direction. Each direction. Recycle cell wall direction entry. Why are you recycling here? Does this really need to happen? That is an extra recycle, I feel. System deseed. And we're back. Okay. Okay, we have the code saved, so we're just going to we're gonna have a recycle here int id. Okay, and no. No, that's not like I just blinked and the code showed up. If it was the correct code, it would be pretty cool. For I is lesser than count, if IDs of I is equal to ID, remove at. Son, you know it. Okay, now I can recycle the ID. Let's spin. I'm gonna keep the old code, okay? I'm gonna keep the old code. If we play our cards right, this, and this will just vanish. Okay. Private plate list. Plate lists. Okay, and these will be 4. Let's go in here. Yeah, new shard is equal to new plate list. Okay, and we can initialize them. Okay, and I love to do that hand action when the AI knows what I'm gonna type. So we just count the number of these that I get to do, and you take a shot. Okay, and that's the game. Cues, cursor, points. This is so. All of this is gonna go, bro. It's just gonna go. Okay, and this cursor and cue, blah blah blah, secret base. I don't need to do any of this. Recycle cell wall direction IDX. So see, this is a recycle inside the cell. First of all, the fact that this code is sitting here in this class and not inside cellwall is just a testament to how bad this is. It's just, it could be so much cleaner. Inside cell walls direction IDX, we have pointers to this array. So every time I want to recycle, so I like this class has the ability to recycle exactly the plate inside a cell wall in a certain direction and a certain index, right? So that value is right now the array entry. Okay, so this is just going to translate to recycle that specific entry, right? Plate lists of direction dot recycle. Now we have to make sure that this is exactly the this wherever this cell wall is being populated, we are getting the correct index in there. So we're gonna pull apart this code, cell walls entry. This will just work out of the box. This will work out of the box. Will it? What is the entry cursor, man? Whatever it might be, this cursor value right here, okay, this is going to turn into the allocate. Now check this out. Check this out. You ready? You ready? Ready to overhaul some code? Okay. Flat plates. What was it? Plate lists of dir dot allocate. Okay. Cursor of I is equal to minus blah blah blah. Cursor. I don't have a setter, do I? I don't have a setter. Wait. Let's get the setter then. Setter. Allocate public void set int idx vector for value and int id if it's in the buffer size. No, just do it without that. Just allocate for me. Can you allocate for me? No. Val comma int id. Come on, bro, just allocate for me. We're going to return the index here. Okay, allocate. So all of that code is now coming in here. You see that? If it's -1, then return -1. Data cursor val IDs says to ID return cursor. Bam, bam. Okay, jix. That's my bookmark. Plate set wall position blah blah blah. You're just wait. Why did it go away, dude? You were almost there. Plate list direction. No. I think you don't know what you're doing. So, oh, sorry. That's why it doesn't know what it's doing. Plates lists direction dot set comma index. I think that will dirty set it also. I don't need to do that. Is something wrong? Okay, what's going on here? Var and cursor. So this is the entry, the index. Oh, so now this is where this code really messes up. I knew this was gonna happen. I could see it coming. It's all right. This is just how I learn. If I was more Giga brain, I would just be able to foretell this happening. This cell wall entries dir cursor. This index, okay. This is going to get this cursor value over here, and then it's going to change. Every time we call recycle, it will change. So the recycle won't work it won't work. See, it's recycling that entry, and the entry cursor goes up, and then it adds the cursor in this. But these values we are changing because we're compressing the, in every add and remove is sequentially, it's changing the cursor, it's changing the indices. Ah, that's the problem. That is the problem. Can we add pointers? Should I do a pointer list? If it was a pointer list. Oh. Oh. Wait, does cell wall have an index? I know what index it is, right? Wait. What am I missing here? It could just right? Pointers, list of pointers is not that heavy, is it? Man, okay, let's see if this works. Because each of these are already in that specific direction, right? I still don't have the height and because they're being removed in serial. No, this will just work. Let's just try this, okay? Recycle, cell walls, direction. This IDX is now ignored. Oh, I don't know what's gonna break here. See, because I'm like every time I reconstruct, I am clearing the whole wall anyway. So since this is ignored now, I can just do here. Let me just copy this. Okay, we don't have to run this loop at all. Just just clear the wall for me. Okay, recycle this entry cursor. Recycle. I think this is extra. Okay, cell. We can just in the set. You just send the cell wall. Just send it whole. Okay. Yes, please change this. Please change this. Thank you. Okay. Cell walls entries. Now let's see where all I am addressing this. Initialization. Recycle index. Now wait up here. This will also go and this will just be 0. Bruh. Bro, will this work? Prepare for crashes. Incoming crashes. Or not. Or it works butter smooth. Can't see anything. Yeah, because I'm not rendering them, that's why. Shall we get the rendering code working? Okay. Next is not being called. Fill, reconstruct. Where are you drawing this, sir? Update. If dirty is greater than 0, this points is no longer being used, I think. So we just do thank you. And here we will do if plate list bake goes through data count discard. Okay. Sweet. So I don't even have to like clear those arrays. Am I calling the clear on them? Wait, clear. Yeah, these plates need to be cleared here. Plate list of 0 dot clear 1, 2, 3. Didn't get that right, did you? Thank you. Ooh. We got holes in the walls, ladies and gentlemen. I'm reminded again of Sapporo. Okay, who's gonna make a guess why this is happening? Is this a recycling issue or it looks kind of cool, like the world is disintegrating. Is this an off by 1 error? We will never know. Touched true. The logic here seems pretty sound. I think there is probably something going on over here or over here somewhere. Clear the whole wall. Set the cursor cell wall entries. Cursor count plus plus entries. Don't think I even need these anymore. No logic is being used here, right? Nope. Recycle index. So each direction will get cleaned out. This is an ignored entry. Direction cell wall. This buffer size will now be plate buffer size. Yes, buffer size. Now this buffer size can go down. Where all are you calling this? Cell wall reserve. Points, cursors. Next points. All of this is gonna go, dude. Underscore plate lists. Sure. Contains key I fill. Reconstruct. Something up here, man. I'm pretty sure. Each wall was being cleared completely over here. So I'm doing the exact same thing here. Let's just follow this code. Recycle this cell wall. All entries in this direction, if they have that cell wall, so then you just remove that one. It's a pretty clean setup here. Pretty clean setup. And is it the dirty flag? Dirty direction plus plus. I think this is the recycle calling touched. Yes, it is. Not the correct size, huh? Count 0. So now all those unnecessary buffers, those extra buffers that I have that I was just sending to the GPU for no reason, not happening. Not happening anymore. But there are holes in my walls. Is it not placing them? Because it's not called any recycle right now. It's not even placing them properly. Cell wall. Active cell walls index. Everything looks good here. Is it this recycle? Can't possibly be running out in any way, I think. World renderer. I like it. I like the way it fills up. It's looking like it's placing something and then it's lifting it up and placing it elsewhere. Would it be doing that in this code? I allocate, I return count plus plus. Wait, count plus plus, huh? Yeah, it updates the count later. That's fine. So you allocate over here. If cursor is equal to -1, return -1, data cursor is set, CW is set, return cursor. There's no way this is repeating, is it? Underscore data. This copy works, right? This is a value copy, I think. Huh. Huh. Whoa. Guys, I think there's something that might be wrong here. That's actually pretty cool though. Gives me ideas for new particles we could have. Fascinating. This sounds like a curious case of buffer overlap in the GPU. Do you feel? So this set data is not set data it's probably not rendering this, and if it's rendering it, it's some data somewhere is going. Is it discard the particle batch set instance set data discard? That's what's happening. I think the code is fine. The code is A-OK. If it bakes and if the count is greater than 1, is the set data not instance vertex buffer? Aha! Aha! That could be it. I think that could be it. Wait, particle batch. What's your draw call? Count. I think that's it. Same triangle list is going in. I think that could be part of the problem. Wait, cell walls. Recycle cell wall. This is happening within the count bounds. So if a cell wall is, if it matches, then we remove at I. If count is equal to 0, return. Am I doing that in the wall shard? Could that be it? I doubt it. There's something up with the recycle code, I think. Because every time a cell wall gets placed, it is calling this recycle, which has to be the culprit. I doubt that it's this line that we removed. Because when this set is called, right, like this value is injected into the array directly. So I don't need to clean out the previous value. Especially since I was already clearing them up here. Wait, let's look at that old recycle, see if it was doing something else. Not this one, this one. See, if it's 0, it's not even being sent. So There's no way that this is happening. Allocate. There's no way that is being called. Nope. It has to be these. Every time this cell wall is recycled, so when the whole cell wall is recycled, where is this? No. There's another recycle here, I'm sure. This one, which is called from over here. Is this accurate? I don't think this is accurate. What is this count? Oh, count in all directions, huh? Okay. Then it makes sense. Count plus plus. Okay, that's fine. But is that the only place you're being called? That is the only place you're being called. Replace every direction of this. Clean it out, remove NQ. And it's bulletproof. Why is it not working? So the only difference is this procedure is not happening. And this check is not happening for all of the entries. And this is just a set to 0. That's it. Which I'm not doing anymore. Entry cursor also not required. That's tough. So close though. So close. So it's already placed the wall. It's now cleaning up the wall. There was an entry there before. Assuming there was an entry there before. There has to be an entry there before. That's why this recycle got it here. So is it that it removes that entry and then, well, then buddy, populate it again, right? Oh, okay, I need fresh eyes on this. How long do we go? All right. Thanks for tuning in. I'm gonna. We have not admitted defeat yet. We will get back to this. We will make this work. I will make this work. Thanks for tuning in, guys. Infinite bliss to all. I'll see you in the next one.